A distance time graph shows the movement of an object over time. A straight line shows that the speed of an object is constant. The steeper the gradient of the line, the faster the object is travelling. A horizontal line means the object is stationary. If you calculate the gradient of the line, you can work out the object's speed. We do this using the equation speed equals distance over time. If distance is measured in metres and time is measured in seconds, then speed is measured in metres per second. To calculate this person's average speed between 0 and 4 seconds, we need to know their distance travelled in that time. If we read up to the line from 4 seconds, we can see that the person travelled 6 metres. Speed is equal to distance divided by time, which is 6 metres divided by 4 seconds, so their speed was 1.5 metres per second. To calculate their average speed over the entire journey, we need to know the total time of their journey, which is 12 seconds. If we read up to the line from here and read across, we can see that they travelled 12 metres in total. Speed is equal to distance over time, so their speed is 12 metres divided by 12 seconds, which is 1 metre per second. We could also describe their journey step by step. This person started by walking 6 metres over 4 seconds. They then stopped for 3 seconds, remaining stationary, before walking a further 1 metre over 3 seconds, and finally speeding up to travel a further 5 metres in 2 seconds. Unlike the journey in the graph on the left, our speed is not always constant, so a distance time graph does not always have straight lines. Sometimes an object will accelerate, so the graph curves upwards, or decelerate, where the curve levels off. We can calculate the person's speed at a particular point, for example at exactly 9 seconds, by drawing a tangent to the curve. Bear in mind that for some exam boards like AQA, this is for higher tier only. To determine the speed at 9 seconds, we read up from 9 seconds until we hit the curve. We then draw a tangent to the curve at that point and create a triangle to determine a distance travelled and time taken for our tangent. In this case, our tangent goes from 7 metres to 12 metres, which means the distance travelled is 5 metres. The time taken is between 5 and 13 seconds for our tangent, which means time is 8 seconds. You can then use the speed equation as normal to calculate the speed at that exact moment. The speed is 5 metres divided by 8 seconds, which is 0.625 metres per second. Here are some practice questions for you to try. Pause the video and give them a go. The third question is for higher tier students only for many exam boards. At point A, there's an upwards curve, so the person is accelerating. At point B, the line is straight, so the person is moving at a steady speed. At point C, the line is horizontal, so the person is stationary. And at point D, the gradient is decreasing, so the person is decelerating. The person's distance travelled in the first 8 seconds is 4 metres, so we divide this by the time taken, which is 8 seconds. 4 metres divided by 8 seconds is 0.5 metres per second. To determine the person's speed at exactly 11 seconds, we need to draw a tangent to the curve at 11 seconds, and then create a triangle to determine distance and time. For this tangent, distance is from 8 to 9, which is 1 metre, and time is from 10 to 12, which is 2 seconds. Speed will be distance divided by time, which is 1 metre divided by 2 seconds, so the speed at that point is 0.5 metres per second. Bear in mind that you'll have different values for distance and time depending on the length of the tangent that you draw, but you should still come out with a similar speed in the end.